Well, good morning, everybody. It's a pleasure to be here this morning. My name is Mark Kieser with Kieser Associates. We've been around here in Michigan for about 33 years, if my math is correct. I've been working on water resources projects for about 40 years. Hail from Michigan Tech, where we did a lot of work over in Green Bay of Lake Michigan, dealing with issues like harmful algal blooms and algal blooms. And so for us, the work that we were contacted about, or the issues that we were contacted about here on Black Lake, really kind of falls in line with the types of work that we do in lake management, watershed management. And we tend to take a little bit of a different perspective. Everything costs money. Any action typically costs money or has some resource allocation to it. So one of the keys that we always say to expending any kind of resources is understand what the problem is, understand what the potential benefits are of any solution you propose, and have some expectation of outcomes. I think so often what we've seen in lake management over the last couple of decades has been we love to chase shiny objects sometimes. We spend money and nothing comes out of it, and that's oftentimes because we don't really have a good understanding of what's happening in the lake or what those solutions may actually do. Does it really solve a problem? So when we were approached about 2 years ago about assisting the Black Lake Preservation Society with some of the issues that they had seen, as Rusty pointed out, in 2020, 2021 with the harmful algal blooms, we basically said, okay, well, what information do you have that would give us some idea of maybe what you're looking at here, what could be causing it? And they said, well, help us assemble that information. So we basically said, well, this should be a phased approach. You know, we gather information, we assimilate it, we gather more information, review it, and then begin to form kind of a good picture of what we think is happening. So what I wanted to do today is just do a couple slides here on introducing this notion of what is a harmful algal bloom. That's the acronym HAB. We use small s, harmful algal blooms. Typically what these are blue-green algae. And blue-green algae is kind of a misnomer. These are actually bacteria. It's called cyanobacteria. It's a real primitive form of organism. It's photosynthesizes like algae, but it can do it on its own without sunlight. It's really kind of this unique creature. It's been around for eons. But what we've seen, not only here in Michigan, but throughout the United States, but even globally, this last number of years, we've really been seeing a number of reports of these harmful algal blooms. Rusty talked about it on the Chesapeake Bay. These are really serious issues, and you look at it and you think, what is going on with the lake here? And so what I'm going to do is I'm going to take just a slight overview here, a few minutes to kind of create the picture around what we're dealing with here on Black Lake, and then get into some of the details of the work that we've done. Now, as you heard earlier, some of these cyanobacteria actually can produce toxins, liver-damaging toxins. These are threat to animals. You don't want to be in contact with these blooms. You don't want to be swimming. You don't want to ingest it. And in fact, it's gotten to the point where regulatory agencies are looking at saying, well, these, how do you deal with these things? And we've talked to, for example, Wisconsin, some of the plant harvesters. So, you know, you can treat plants in a lake with chemicals, you can harvest them with big rakes. The state has even said, look, if you have blue-green algae mixed in with your plants, you shouldn't be physically, mechanically harvesting them, because you aerosolize these tiny little particles, and now you can breathe them into your lungs. So this has gained a lot more attention, especially in Lake Erie. You've seen these horrible photographs of, you know, satellite photos of the entire western basin of Lake Erie is this bluish-green color. In 2014, it shut down the drinking water supply for the city of Toledo. It's a big deal. And so here in Black Lake, obviously, you'd never seen them. It was not on the radar, and then suddenly in 2020, they show up. And so why now? What is the issue? And that's what we were tasked to do, is come in and try to determine what's causing these. So this is a little bit of a larger print slide from what Rusty had showed you in terms of what was seen in 2020 and reported. in 2021 as well. And what's interesting is there was evidence in 2020, there were a couple more incidents in 2021. These numbers are kind of this is actually MC means microcystin. That's the toxin one of the toxins associated with blue-green algae. These are, it doesn't take much to exceed a water quality standard, a health and safety standard, and so there were some exceedances here. What's interesting is the response. Now, the agencies realize this is an issue, but again, it's a timing. These things can pop up after a couple quiet days, warm days on the lake, but you get a wind, they dissipate. So you can get out there and test, but it's hard to capture these when they're in bloom. You can do lab testing to affirm this concentration of toxin, but then there's delays. It takes a day or two to determine whether or not these are actually have a toxin content to them. So there's this process of sampling, reporting, public communications. The state has basically said, look, we can give warnings, but they're usually after the fact. So if, the response is if you see it, avoid it. And I think that's what Rusty talked about, is because it has been seen now for a couple of years, it's that educational side of it, is if we see it, we got to avoid it. But then the question is, okay, so now what? Is this something that we have to live with? And that's, again, part of our quest to come in and look at this. So there may be a number of causes for these blue-green algal blooms, these harmful algal blooms. There's not a 1 + 1 = 2 equation that we can say, hey, simple variables, we know exactly this condition, it's going to happen. These are weird, this is biology, so there's nothing that's predictable necessarily for these algal blooms. Nutrients are typically a common target for the reason why this is happening in Western Lake Erie Basin. There's a lot of agriculture, and a lot of the dissolved phosphorus that goes onto the fields as fertilizer washes into the lake, and dissolved phosphorus is sugar water for bacteria, cyanobacteria, even green algae. So as we talk about some of the nutrients, carbon is one of those, that's the C, nitrogen, that's the N, phosphorus, that's the P. We end up typically focusing on phosphorus. That's often kind of the limiting nutrient that goes into our water bodies. This can come from several different sources. So it's important to understand is if this is happening, if it's related to nutrients, is there a particular source that's very evident that may be causing these issues? Rusty mentioned the onset of zebra mussels in the early 2000s. Zebra mussels tend to eat, they're filter feeders, and they siphon out green algae, which is what we think is that's the basis for the food chain in a healthy lake. So they're siphoning out the green algae, digesting that. But if they cycle through the blue-green algae, they actually don't digest that and they spit it back out. So what you're doing is you're filtering out the green algae, which are the competition to the blue-green algae, and you're given this ideal condition of, hey, we're blue-greens, we don't have any competition, let's grow. And so, the ecological side of this comes into play, looking at zebra mussels and filtering an issue. And then certainly you've got physical conditions, or lake levels, temperature. This is actually a failed septic tank, if you will. This is kind of a gross example of somebody's out on their lawnmower and they fall into their septic tank. There's our friend the zebra mussels, not our friend. And there's several different circulation patterns in a lake that could help drive some of these conditions. And so there's a lot of complexity associated with saying, hey, what's causing these blue-green algal blooms, these harmful algal blooms? The other thing that's fairly interesting here is we oftentimes think of blue-green algal blooms, these harmful algal blooms, in waters that are really polluted with nutrients and runoff from farms. Well, the last number of years, a lot of the scientists around the world have said, we're starting to see these in very, very clean lakes. And this is kind of the example of, hey, they're starting to see these come up in these very low nutrient systems, which is what you have here. It's a very clean lake, very low in nutrients. The second citation, oligotrophic lakes, that's what we talk about, a Walloon lake, a Torch lake, a Black lake, pretty much an oligotrophic lake that has very little nutrients and not much plant growth. We're starting to see these blooms pop up in these lakes where you thought, it would never happen here. We're actually starting to see that, and we're seeing this worldwide. So this is not unique to you guys, but it's certainly, as you think about this, hey, this is our lake. Is there something happening that we can do to address that? So today what I'm going to do for the rest of our conversation here is talk about a couple of different efforts that we've been working on with the Black Lake Preservation Society. We first started talking about this, we said, we really need a phased approach here. Let's just not make an assumption and try to say, there's the culprit, let's go after the culprit. It was really saying, let's understand the system first. As we get more information, we need to gather more information. That's the phased process. We'll also talk a little bit about the vegetation monitoring, and Rusty's slide, that last question of, is there an invasive aquatic plant that's coming into the lake that could affect these nearshore areas, but there's also a balance between the plant community. You think of the plants that are growing with roots in the algal community. So getting a little bit better understanding of what's happening in the vegetation in the lake, we suggested an update. There's been a lot of work that's been done in the past, but nothing in the last 5 years. We'll talk about that briefly. Importantly, we'll talk about what we're seeing so far and what that could lead to in the future. So let's jump in. The next couple of slides, I'm just saying, hey, here's the outline of what we're proposing to do on these different phases. The background is, what do we know? Phase 2 is saying, well, based on the gaps that we have now, because we just don't know it yet, what do we need to monitor? Phase 3, we're already there, we're working on that now, so it's really kind of a detailed focus on, hey, we've started to whittle down this wide swath of issues or contributions to harmful algal blooms. Now we're a little bit more focused in terms of, hey, we think we've got some things that we need to better understand. The future is there anything we can do with it? So phase 1, we started last year when we first contracted with the Preservation Society, and it was really saying, well, let's start the conversations. What's happening here? What do we need to know? Reviewing some of the existing information, and then step 3 here is really kind of important. Step 3 is what we call a mass balance. And so if we think of, in the old days, now we have all online banking, but your checkbook. You would write in your checkbook every entry. You would write in when the deposit went in, you would write in when you wrote a check, and so you're always keeping a balance. You're maintaining that eye on your balance in the checkbook. That's kind of what we talk about here in the mass balance. What we're saying is, for the lake, if we look at this in terms of nutrients, particularly phosphorus, is what's coming in to the lake and what's leaving the lake, what's staying in the lake. That's kind of that checking account balance of phosphorus in the lake. If there's lots of phosphorus coming in and very little leaving, that means what's coming in is staying in the lake. That's probably being recycled through the ecological system. We'll talk about what that came up with in terms of findings that we're seeing. Phase 2, we're already into that. We're pretty well completed on that. This is where we said, look, we got to do more testing. We got to have a better understanding about the lake. And then we'll update some of what we have assumed in phase 1. Phase 3, we started this May, and it's more detailed sampling. It's kind of narrowing in that focus on the concerns, and you'll start to see kind of a repeat here on the septic systems. And so we'll focus on that heavily here in the next section of this presentation. One of the things that the BLPS recognizes really important is we have this wonderful opportunity to develop a watershed management plan. As Heather pointed out, is once you have an approved plan, and that's approved by the state, and it's approved by EPA, that's kind of, now you're opening the funding checkbook, if you will. There's opportunities for funding. But with that, anything that you want money for in the future, it has to be in the plan. So if it's not in the plan, the state will say, hey, it's not in the plan. You don't qualify for that particular set of funding. So What was really important here is to make sure that what we find here, if it relates to something that needs to get fixed or needs to be managed, it's got to be in the plan if we want future funding through that process. So there's an iteration that we have here of working with the tip of the mitt on the results that we're finding. And lastly, it's out in the future. What can we do? And again, this comes a little bit back to, is it the watershed? And that the WMP, the watershed management plan, or is it near shore? Is it septic systems? This, for example, this is an inset of some of the work we've done on septic systems under the lake, saying, well, what if we had deep-rooted plants between the drain field and the lake? Will that suck up the phosphorus before it goes in the lake? And it can work, but this particular site was a grant-funded site. The homeowner said, I want my beach back. So all of the deep-rooted plants that were there to intercept this drain field, they got covered in sand, and now it's a beach. So there are lots of elements in terms of what's a practical solution and what's sustainable that will come into play here, looking at down the road. All right, so phase one. This is going to seem a little bit wonky. This might be a lot of information. I'm going to walk you through it. And if there's something that you see here saying, I just don't get it, just raise your hand. Let's make sure we don't jump too far into this without answering any questions. This is the checkbook balance. We're looking at phosphorus in this case. So based on the information that we knew about the watershed, yes,
what is TP?
Total phosphorus. Okay. Great question. TP. So we think of phosphorus. There's a couple different important forms. Total phosphorus, which is sticks and mud and dirt, and soluble phosphorus. That's all forms of phosphorus. That's TP. And then there's soluble phosphorus, and that's the sugar water. That's what's dissolved. That's not the sticks in the mud. That's what's already dissolved. That's the sugar stirred up in the glass that you don't see the sugar crystals anymore. That's the condition that's really important for the lake. Starting out, we just said, what's the total amount of phosphorus coming into the lake based on what we know? And what you often see when we talk about these mass balance endeavors is, hey, what are all the sources of phosphorus coming into the lake? And what's the distribution of those? Now for us, it's pounds TP, pounds total phosphorus per year. And this is coming from the different sources. So on an annual basis, it's close to 13,000 pounds of phosphorus coming into the lake. And then all the tributaries, that's about 11,000 pounds together. But then you start to break these out in terms of, all right, what are some of these other ones that are really important? The upper black is really important. The radius is really important. And you can see it, of the tributaries, 85% of those comes in from those two tributaries. So that begs the question, well, if we're looking at the whole watershed, we're looking at all of these tributaries, which are the ones that may have the biggest impact on the lake? And that kind of translates down the road with the watershed management plan. So what we noted here was, okay, these are what we would expect as the sources. There's atmospheric, the wind brings in dust and dirt. There's septic systems. We estimate that based on the number of homes, the age of the homes, the likely age of the septic systems. The runoff, that's from the lakeshore in this case, and then the tributaries. And so it just gives us that chance that, hey, we open up the checkbook and say, where's our money going? In this case, where's the phosphorus coming from? So that was kind of the initial cut at sources. Now when we break this down to say what comes in, what leaves, and what stays, this is how it breaks down kind of on a preliminary basis. So the numbers are a little bit hard to read, but the size of the circle is kind of, the circles on the outside are kind of intuitive in terms of, is it a big source or a little source? What's interesting here is the amount of phosphorus that we calculate coming into the lake, and then you take what is estimated to leave the lake, means that there's about almost 4,000 pounds per year of phosphorus coming into the lake that stays in the lake. That stays in the water column, but the lake gets flushed out less than a year, but oftentimes that's also what accumulates in the sediments. So right now, everything that's coming in, a portion of it is staying in the lake, a portion of it is flowing out of the lake. That's important to be able to then keep in mind of, okay, so if we're having these certain conditions at certain times of the year, how important are these different sources at the same time of the year? That's what portends for the next set of work. So here's what we found early on, and this was kind of important because what we're trying to do is say, if it matters, let's look at it. If it doesn't matter, let's not look at it. We know that something changed or something happened in 2020. There was no reports of these algal blooms before then. So, you know, what happened in that period of time? The tributaries, we say there's no smoking guns. Even though the upper black has the most amount of phosphorus coming into the lake, it's at a very, very low concentration. It's a very clean river, if you will, in terms of nutrient loading. So there's lots of water, a little bit of phosphorus, but when you calculate the mass of phosphorus in pounds per year, there's a lot more coming from the upper black than some of the other tributaries. You think about that, well, what do we do if it's fairly clean water? It's the largest drainage to the lake. We do a needle in a haystack project up here. Doesn't make a difference where it comes into the lake. Now, it's important to say, well, maybe that project doesn't affect what's in the lake, but it affects what's in the river. So that's the beauty of a watershed management plan, because you're looking at where are these concerns in the watershed. It doesn't always have to relate back to what's happening in the lake. It could be local conditions. I know the fishermen talk about, hey, if there's sedimentation, that wrecks fishing conditions upstream. So there's lots of variables that go into watershed management. Keep in mind what we're doing is we're focusing on the lake itself at this point. So we didn't see any smoking guns with the tributaries. Interesting, and this hadn't been computed before, how much time does it take for one full volume of water to flush out of the lake? That's really important in terms of saying, if it comes in and stays in, it's only going to make conditions worse. So the lake flushes out about every 2/3 of a year. We're doing a big lake in Wisconsin, big green lake in Wisconsin. It's 235 feet deep. It's 7,000 acres, a little smaller than Black Lake. But that's 15 to 20 years it takes to flush out. So they're focused on agriculture coming into the lake. Well, 1 year of agricultural runoff stays in the lake for 15 to 20 years. A huge important notion in terms of what can we do and how long is it going to take for that upstream watershed action to have a benefit in the lake. So this is, hey, the lake's flushing out less than a year's time. Just important as we think about solutions and different water quality conditions. The state actually, DNR Fisheries, the folks at Eagle have said, well, we think this could be sediments. We think that it's nutrients accumulated in the sediments. We know that they come into the lake, they stay, but those sediments will release phosphorus back into the water column under low oxygen conditions. Well, as it turns out, we answered that question. We don't think it's sediments at all. So that again says we're not going to deal with bottom water sediments because we don't think that has any impact necessarily on surface water quality. Septic systems, however, appear to be a potentially substantial source of phosphorus, especially at that late in the summer period. We'll talk about that a little bit more. And the last bullet point here is kind of key when we talk about this idea of these blue-green algal bloom problems. Is this a watershed, a restoration issue, or is this a shoreline management issue? And what we're saying, and this is not to take away from the importance of watershed management efforts, but if this is being driven by a shoreline condition, that's important to know. And that's kind of where we're kind of leading now into the phase 2 of looking at some of the additional monitoring and some of the findings. There was a question, yes, sir.
How did you come to your conclusion on the sediment?
So this is I will admit there's a little bit of overlap between phase 1 and phase 2 findings in that last bullet point. But what we're seeing is that there's very low phosphorus in the bottom waters of the lake. We've sampled the sediment and we've sampled the bottom waters, typically where those are the cold, largely stratified bottom waters. Even though there's low oxygen, there's almost no phosphorus in the water column. I took out a slide that we had of Mona Lake, which is down near Muskegon. That lake was overrun, nonstop harmful algal blooms, day and night, all summer long. And it turns out it was all sediment-driven problems. It was all sediment-driven. So we treated the sediments. And now 4 years from the start of our treatments to now, they've had no harmful algal blooms. Because it was a sediment problem, we determined, hey, we can address that specifically. And so that's the importance of having good information to be able to say, that's it, that's the culprit, now what do we do? Let's do it and see if it worked. So, yes, sir.
So you keep talking about the oxygen level being low, and that keeps the phosphorus.
It could mobilize it.
So what does the oxygen do to the phosphorus?
Yeah, it's basically anaerobic low oxygen conditions. It's water chemistry.
Okay.
So if there's you don't have reduced iron, you could release. There's a lot of complex chemistry involved. But most lakes, when they stratify, oxygen goes away because those surface waters don't mix with the bottom waters. That's when you can have phosphorus release. But what we're seeing both in the early estimations is sediment stays in the lake. We're seeing in our water quality samples that they're literally the surface water concentration, which is low, is also low in the stratified bottom waters. So that means that you don't have the reducing conditions, the chemistry where you'd be releasing phosphorus. Mona Lake, no oxygen, but they had such a significant phosphorus source in the old, historic sediment loading. It would go, surface water would be almost zero, bottom water would be 400. 5 is, at 5 you could start getting harmful algal blooms. So you can imagine that circulation, it was nonstop. So here we just don't see those sediments as the issue. It did help us kind of hone in on where do we have information gaps. And so right now we have a gauge in the lower river that gives us continuous water levels and temperature, and we can basically, we know the geometry at that location, so we can translate that to flow. So we know the volume of water coming into the lake every day, every single day. We're taking measurements, I think, every hour on this little instrument. And it's that's it. It's on a dock. It's a little probe about that long, about that round. It sits down in this pipe in this well screen. It's solar powered, so we can call it up on our phone right now and say, hey, what's the water level in the Upper Black River, and know what the flow is at that time. So important information to have when we talk about what's flowing into the lake and then now what's leaving the lake. So this is a little bit downstream of the marina there on the Lower Black River. Again, it's the same thing. This is right next to the flow instrumentation the dam operators have. If you go down to that, the old buildings there, and you look over, there's this panel of instruments. So we put ours the same location. We know the geometry at that location. It's a little bit more difficult to get the geometry because it's, you got wetlands on one side, whereas in the Upper Black River, you've got seawalls on both sides. So it's kind of square, fixed geometry. There's a question.
How consistent has the water level been, in your opinion, over the last 2 or 3 years? Has it been lower?
It has been. We actually have some temporary data from late last summer through November. I don't show it here, but we were looking at lake levels actually, in addition to the levels here, and it followed pretty consistently what we saw on some of the inflows. Same thing here, same instrumentation. That's kind of a vague answer, but these are translated to flow. So this is the variability. The blue bar is what's leaving the lake on a daily basis across that period of time. The orange is what's coming into the lake from the Upper Black. So it's it's about 50 to 80% of the water coming in from the Black River through this period. But it's going to vary. Lake levels varied somewhat over the year, but it wasn't dramatically. You didn't see feet of difference. We put it in August. We pulled it out in, I think, early December of last year. And so I don't present the data here, but we have some of that information. Okay, so This is where all the sites that we hit back in 2023, we went back to some of these in 2024. At the bottom, these are the tributaries we sampled. In the middle, we did some sampling of nearshore. When we talked about that, we looked at groundwater right next to the edge of the lake. And then the open lake sampling, which gives us a lot of critical information. Now, the beauty of what the BLPS is doing is, and the work that Marie is doing, is we just have just a hugely robust data set on the kind of the upper water quality. But we've also then looked at sediments. You know, what do the sediments on the bottom of the lake look like? That's actually in a big stainless steel salad bowl. That's what the bottom sediments look like on the lake. And then just some preliminary numbers around, hey, what have we seen in the phosphorus? Basically, most of the phosphorus is coming in from the tributaries year-round, when we think about that. And a good portion of that is contributing that soluble phosphorus as well from the tributary, the upper black, just the upper black. So these are some of the data that Marie collected last year. This is like, oh my gosh, this is a mind-numbing figure. What does it mean? This is water depth. So this is the surface of the lake. This is the bottom of the lake, about a little over 50 feet. And so all of these lines here represent the amount of oxygen in the water. Oxygen is needed for fish, all aquatic life, except life that's adapted to bottom waters with no oxygen. But what happens is 5 is kind of this magic number. The state says, well, look, if you're above 5 milligrams per liter of oxygen, that's pretty much good for all fish. But what you see here is there are certain times of the year where the lower 10 feet, maybe 12 feet, has little to no oxygen. That's the condition where we would expect phosphorus to come out of the sediments, but it's not. On the right is temperature, also somewhat important. So we think about, you know, this is pretty deep into the water column in terms of, you know, same temperature at the top as it is at the bottom. But when you get near the bottom, this is what hardly ever circulates. Even as strong as the wind can blow, it's hard for the whole lake to mix down to the bottom. So the temperature at the bottom of the lake is fairly consistent. There are a couple occasions where there might have been some events where it got fully mixed. The beauty is now you have a data set where there's data collected every 2 weeks. So maybe it doesn't have to happen every 2 weeks, but this information, until we went out last year, the BLPS went out last year, was hard to find. Even the DNR fisheries folks spending money on stocking the lake and managing, you know, especially the sturgeon, these data were not available, and now they are. This is one of those slides of like, this is what? This is the Lacospermia. So this is one of the species of blue-green algae that we found in the sediments. So remember that picture of the sediments, kind of this orange light colored goo on the top of the sediments. We took some of that off and we sent it to a laboratory to say, hey, tell us what kinds of blue-green algae are in here that we might be seeing as are kind of resident in the lake. This one is what they call nitrogen-fixing blue-green. It doesn't need much nitrogen, it just needs the phosphorus. And so if there's enough phosphorus, it can really kind of take off. Some of these species have gas vesicles, and whatever in nature triggers them, they're on the bottom of the sediment, or the surface of the sediments. The gas vacuoles inflate, they come up to the surface. So that's why in harmful algal blooms or blue-green algal blooms, you'll see it's a floating mat. These things are pretty buoyant, and so this can go from the bottom to the surface, and some of these can produce toxins. This one can produce toxins. What we don't know, and Rusty is prepared with bottles to go out and sample a surface bloom. What was done in the past by the state is, yes, the toxins are present, don't go in the water, but what we don't know is we don't know the species of blue-green algae at the surface. That could matter, could make a difference. So again, there's more to do, but this is some of the wonky data that we think, oh, this is really interesting. We didn't know this. It may not play out 100% now in our explanation today, but it could be important for us as we look at future conditions. So this year, we've been doing more monitoring, a little bit more focused, and we'll be talking about integrating it with watershed management plan. So this is, we started out here, and now we're beginning to narrow our focus down. And what you'll see is mostly septic system types of conversations. And we'll talk about why that is. So we've done some sampling around the lake. Now, there are lots of programs that could go along the shoreline, like beach monitoring programs, public beaches. Somebody goes out, wades out in 2 or 3 feet of water, takes a water sample, comes back and says, ooh, blue-green algae, microcystin, shut the beach down. So it's sometimes hard to catch that. You don't always, because the lake is very dilute. The wind's blowing, you get waves, it's mixing with 10,000 acres in one little spot on the shoreline. So what we did is we sampled groundwater right next to the shoreline. And our sampling points were downstream of old septic systems, older septic systems. So the data that we talk about next these are shallow groundwater samples that were taken downstream of an old drain field just before that water coming from the drain field would come into the lake. So what that tells us is it's not geese on the beach that are causing any disruption. What we're seeing here is representative of the drainage coming from a septic system. So this particular system was an older system. The volunteer here, they typically pump it out every 4 or 5 years. It's seasonal use. So as we say, for example, the 4th bullet point here, 85 days of use. That's basically saying, hey, there are 2 of us living here full-time for 60 days, or for 30 days, that gives us 60 resident days, and we have some guests, that adds up to 85 days. All that says is, how much is that septic system being used? How many times might the toilet be flushed, showers being taken? Otherwise, it gives us some sense of what the volume of waste is going into that system, and how far is the drain field from the lake. So at this particular location, let's just focus first on the phosphorus side of the question. We also sampled another location that had a much newer septic system. The drain field had been rebuilt way away from the lake. The nearshore sampling showed nothing, no phosphorus. So that tells you, hey, a new system away from the lake, that's a good thing. The older systems that are near the lake, the question becomes are they putting something in the lake that could trigger an algal bloom? That's kind of our premise. And so we said, let's start taking a look at that. Let's get some field data and take a look at what's happening. So this graph on the right there's our dissolved phosphorus. That's soluble. That's the sugar mixed in with the water that's now all dissolved. That's the sugar water for the algae. So in September, after a good portion of the seasonal use, it's pretty high. 0.25, that's 250 parts per billion, 0.25 parts per million. Those are very high numbers. In the lake, it's 5. In the groundwater here, it's 250. So is there a concentration then from that particular system coming into the lake? How does that translate to all of the other septic systems that may be on the lake? New, old, close, distant. It starts to give us information on, could this be an issue? What's interesting here is by December, a lot of the phosphorus has flushed out of those soils, and by May, before the resident use comes back up, it's almost gone. So the system gets used through the summer, it builds up, there's a lot of phosphorus in the system reaching the lake. After the seasonal use is over, groundwater keeps flushing it out, diminishes by springtime, there's almost no phosphorus left in it. Very important for us to understand, given the seasonal nature of a lot of the residency around the lake, is what are the conditions we expect. Importantly, we know the blooms have come in September and October. So as we look at this graph, what does that say about September? To us, we say, hey, that's when you have the most amount of soluble phosphorus coming in from septic systems, is when you're seeing those blooms. Keep in mind, blue-green algal blooms like warm water. They like very calm conditions. So you don't typically see blooms in the winter. You don't see them in the spring because temperatures are lower. So at that time of the year when water temperatures are finally pleasant, you're not shivering when you're going in, you also have high phosphorus loading from the septic systems, at least this one, we think others, that potentially could trigger that condition. So on the phosphorus side of the question, what did we learn through this monitoring is we have very little phosphorus coming in from newer systems. That's what we would hope for, that's what we would expect, and that's what we want. We have high nearshore phosphorus levels for older systems. That's kind of the indicator that is there a condition that's right at the end of the year when the blooms happen, you got lots of phosphorus coming in, and that peak use, that peak seasonal phosphorus loading. But then we see flushing in that particular system over time. So is it kind of a cyclical pattern in terms of the amount of phosphorus coming in the lake that peaks in September, end of the year when that happens? So important information for us to look at. Now let's go back to our mass balance. This is kind of the kicker here. So what we said is the mass balance, this is an annual basis, so lots of assumptions. So we said, well, let's just kind of look at August. So our early look at August in phase 1 said, we think about 19% of the soluble phosphorus, bioavailable phosphorus, the sugar water that the algae want, maybe roughly 19% of the phosphorus coming into the lake at that time was from septic systems. So our new data, that number goes up to potentially 30%. And that's substantial, yes, sir.
I'm been confused. When you say sugar water,
That's an analogy to say the phosphorus that's dissolved in lake water is
okay,
like,
it's not sugar.
it's not sugar. It's not the sugar at the bottom of the glass, it's kind of stirred up.
Okay.
And when it's stirred up, that's when the phosphorus is dissolved. That's when that's a great question. I'll work on that analogy. I've used it for decades. I'll improve on that one. So this is kind of a segue into what we're doing at phase 3. If you'll notice a QR code, you'll notice a link. How many here have gone online from Rusty's newsletter, the BLPS newsletter, looked at that and said, I'll fill out a septic system survey? Anybody here done that? Okay, a couple hands. What we'd like to see is 50% participation around all lake residents. One of the challenges is when you do these surveys, this one only takes about 3 minutes. You don't have to put your name, you don't have to put your address. It just says, hey, my system is about 4 years old. We clean it out every 2 or 3 years. We have 6 people here who live here. It's a real simple survey. What we do is we say, based on the feedback, what are the broader septic system conditions around the lake that, hey, if 85% of all the systems were brand new, I would be telling the Black Lake Preservation Society, it may not be septic systems, but we suspect a lot of the systems are older. We know we've tested newer ones, and the newer ones are, as we had hoped, no problem with the lake. So our interest here is to try to get a good feedback from residents, and you've got a number of different projects that are happening, a watershed management plan, you've got other surveys. This one comes along and say, oh, they don't need that information. We already responded. It would be important for us to get this feedback because I said at the onset of the conversation is, if it's a problem, we have to define the problem. Because if you're spending money on a solution, you need to know if that's really the problem. So this is good information for us to be able to say, do we really suspect this as a key problem? We think it is, but this kind of feedback would really give us a lot of information. Some of the early feedback, we've had some responses is, this is just, we look at this as one of, I think there's like 20 different plots that come out of this Google survey. This is, why do people pump out their septic system tanks? About 2/3 of everybody says we do it because it's routine. Some people say we need some maintenance. A couple have said, our tank is full, we've got to get it pumped out. So there's a couple different options that you could select on a question like this is, hey, how often do you pump out your tank and why? But again, this begins to form the basis to say, if this is a problem with septic systems, is pumping out more frequently the solution? Is that the answer to a liquid problem? So this is why we ask these questions. Now, one of the other little dirty secrets about septic systems is remember what's going into these. It's not your dishwasher, it's not your shower, it's also your toilets. And so we know that as you're waste goes into the tank. The solids are kept in the tank by baffles, but what comes out is liquefied. That's what goes out into the perforated pipes, your drain field, percolates through the soil, eventually gets to the shallow groundwater, and the shallow groundwater moves to the lake. That's why we're sampling shallow groundwater. So one of the issues then with the septic systems is it's not just phosphorus. That's why beaches get closed, public beaches get closed, because they've tested for this bacterium. It's a gut tract bacteria called E. coli, Escherichia coli. And so it's an indicator of, there's a waste. It could be any mammal, but in this case, if it's downstream, directly down gradient of a septic drain field, we know it's not raccoons. We strongly suspect this is an indicator of human waste that's moving through the groundwater. That's what septic systems do. What happens when they're close to the lake, the question becomes, do those bacteria also get to the shoreline, where we swim, where we recreate? And the presence of the bacteria indicates potential pathogens. These are the viral pathogens that we think about that really can cause sickness. We say, hey, don't swim when it's a blue-green algal bloom. We also say the public beaches get shut down because don't swim because there's human waste and there's potential for pathogens there. So it's an issue. Now keep in mind, the state says, hey, we got standards for this. We close a beach down when it exceeds 300. Just keep in mind that 300. So we also looked at, here on Black Lake, another example of, all right, if it's phosphorus, but is there also bacteria? And so this particular site was an older system. It's pumped every couple of years. This is the usage, 70 days, but it's a field that's away from the lake, but it's been there for 50 years. So what is it? What are we seeing in terms of the bacteria right next to the shoreline? There's our standard. That's kind of the bright line standard. There's the levels that we saw kind of along the beach. Some of those exceed the state's total body contact, and those are your swimming, your bathing, swimming, let's keep it at swimming, in the shoreline. So the question is here, is that a risk to the homeowner, to the residents, to the guests, the kids, the grandkids? It's an indicator that, in this case, these older systems not only are putting soluble phosphorus in the lake, you also may have a bacterial issue and you're swimming in poop. Put it bluntly. Steve.
What is the S2 to S2?
These are confidential locations along a beach.
Oh, these are three different locations.
3 different locations on the same beach, about 12
Well, which
feet
one
apart.
was on those 50 years old?
What's that?
But it looked as though it...
This is all the same site. So what we did is, because septic system plumes aren't perfect, you get a... So
there's
you sample
three samples on one
Actually,
site.
there were 6 samples.
Oh, on one site.
These are the
Okay.
3 out front where we think the water's coming from that drain field. 3 of those had these bacterial levels. And at the same time, their phosphorus levels, similar to the other site, but the first indication, lots of phosphorus, no bacteria at all. None. This site, phosphorus, but also bacteria. And so the indication here is, that poses the question, how many other old systems are out there? It's informational at this point. Like if you're filling out a septic system survey and say, that's kind of where I fit in, we would just pose the question, what are the conditions? Not only for the broader lake, but also just for your, what does my beach look like? Is it, what am I swimming in? So I'm not trying to be a run henny penny, the sky's falling here, but what I'm saying is there's a reality associated with septic systems. They drain the waste that we put in the systems next to a lake, they make it to a lake. And so what is that condition on Black Lake?
Okay, so those though are inland, not water in the lake.
Those are, this is a foot down, you're playing in sand, digging sand castles, you get down there, there's the water.
Offshore.
Yeah, so this is about 10 feet from the water's edge. Okay. The reason why we don't sample it in the water is that if there is bacteria, there is it from the goose or from the geese that are up on the beach, they're pooping and defecating. This says, when it's in the groundwater, it says this can only be associated with a drain field. So what we're trying to do is just eliminate the possibilities of saying, hey, it could be something else. Here we're saying, a pretty strong indication that this is from the septic system drain field.
But there is no sample in the water, so we don't know that the water is contaminated to
That's
that same
absolutely
degree.
right. But I go back to the sandcastle analogy,
Yep.
the grandkids. So one of the things that, and I give Steve Speth from the Preservation Society credit for this, he said, well, if these conditions are out there, how do we determine if it's at more locations than just this 2 sites out of 800 plus sites on the lake? And so what the Lake Preservation Society said is, well, let's come up with a volunteer sampling program, and this is what we plan to do in September. So this is a pitch that if you have a system that's older than 20 years, a lot older than 20 years, and you only pump it out every couple of years, whether it's seasonal or year-round use, your drain field is close to the lake, are you a candidate? So this middle one is shoreline cladophora. You've heard Tip of the Mitt for years has been doing these great surveys of cladophora. This is an attached green algae, not blue-green, but attached green algae. It's on the rocks right along the shoreline. It's really slimy. You're out there in your dock, you look back and there's this patch of rocks or, cobble, and why is it all green right there? The likelihood is that just up from the lake is where your drain field is. So the cladophora surveys are kind of a great indicator. Is there something breaking through the lake? Because this will grow with a tiny bit of sugar water, just a tiny little bit of sugar water, but it's got to be concentrated. So this is where your septic system mixed with your groundwater is coming out to the lake, and you have these green patches on the rocks. It's likelihood that you have breakthrough. Now there's been all kinds of methods that have been tested over the decades. Hey, let's look at whiteners that are in laundry soaps to see if they're in the lake, and we'll drag equipment. Cladophora tends to be a great indicator. This won't grow in warm conditions unless there's lots and lots of phosphorus. So if you're seeing this in August and September, we're just saying make a connection there. Maybe this is you, and maybe you're saying, hey, let's figure out what we have. That's what we're trying to get at here. We go back to our first survey that we did, cladophora, was 1985 on Walloon Lake, actually. That was one of the things we did to say, in Walloon Lake, it's a very clean lake, very little tributary coming in, problems coming in. What is the septic system? So Ernest Hemingway, his family lived on the lake. I don't know if they still have big old house. They remember the grandkids at the time, back in the 80s, so that dates me a little bit, saying, yeah, when Grandpa put in 2 55-gallon drums filled them with pea gravel and hooked up the pipes to it. And so just like Black Lake, Walloon Lake, there's lots of value there, shoreline value, property value. And that was a big question. So what do you do with septic systems on Walloon Lake that are problems? This is kind of, a lot of the work that the Tip of the Mitt has done has been showing these problems now for 20-some years. Their reports kind of show indications of the shoreline areas where you're seeing this. What we'd like to do here is, if you have interest, this is all confidential. We come to your site, we do probably 5 samples along the beach. We look for E. coli. This is kind of a field test that we do. Maybe collect a phosphorus sample. We would provide you the results, but they stay confidential. The notion that we're looking at is, hey, if this is a broader problem, especially the bacterial side, people should know about it. And emotionally, you're saying, hey, are you swimming in poop versus, well, phosphorus. You don't see phosphorus, and blue-greens, they stop happening. So is it important? So this is kind of trying to bridge the gap a little bit in terms of what we do. It's really simple. We put this, that's about a 4-foot long pole. There's a hose in it. That bottom foot is just a stainless steel screen. We pound it down into the water table. We turn the little pump on. Water comes out the hose. We put that in our jar. We pull the pipe out. So it's kind of, you wouldn't know we were there the next day. But that's how simple it is. So if you have interest in this, talk to Steve. We would also say you could express that interest if you do the online septic system survey. So it's not over, but we're close. I won't let you out yet, but we're getting close. One of the other interesting things that came up in our conversations, Rusty pointed this out, was this question of there's a lot of weed growth especially at the mouths of some of the tributaries. People have been noticing it. We noticed it last year. The question is, these are milfoil species, and if it's Eurasian water milfoil, that's invasive, that can go wild. Variable milfoils out there, northern water milfoil, those are native, and sometimes they can get a nuisance level, but Eurasian water milfoil or hybrids of that, once they're in the lake, that's where you may want to try to catch them early and put those in check. So what we were asked to do is say, hey, Mark, let's get an update. I suggested, they approved, getting an update on the full comprehensive picture of what's in the lake in terms of the plant community. At the same time, let's see if we really have an issue here with an invasive. That's some genetic testing that a lab in Colorado does. What we'll do is we'll make historic comparisons, what we found in 2024 with what was found in 2005, right at the tip of the mitt. There's a couple other reports in between. We just did our survey a week and a half ago in the lake. So the coloration of the dots is a little bit different, but just to say on the right is all the information that we gathered from each of these locations. We have really good details on the plants that were present, how dense they were, how dominant they were in that patch. And I think just early on, it's kind of fun to look at, hey, in 2005, wherever you see an orange dot, where that was sampled, there was no plants growing, no rooted plants growing. As you look at 20 years later, now a lot of the areas that didn't have plant growth years ago, you could maybe start seeing a little bit more growth. Doesn't mean that's bad, it just means what's the difference between these. Lakes can either be macrophyte dominated, rooted plant dominated, or phytoplankton dominated. In this case, there's not a lot of weeds growing in the lake. So understanding what the condition is, the plant community, but also is there something that needs to be treated is important. This is a little bit separate from the septic system work you did, but also important information that the Preservation Society is looking at. All right, so a couple more slides and then we're done. So what's next in terms of our scope? We're wrapping up a report from phase 2. We've got a couple things in this current phase. Is the survey that we talked about. Is everybody get online, spend 3 minutes. The beach testing program, and then a wrap-up report. The other important aspect of this, and we've been interacting with the tip of the mitt, their subcommittees, Marcella's work, is we're sharing information that we're gathering. As soon as we reviewed it, we're sharing that with tip of the mitt. What's important is they develop the plan. Having this stuff in place early is really important to make sure it gets in the plan. If it's not in the plan, state won't fund it. So kind of an important aspect. This is some of the work that others have talked about. I won't go into this, but there's just a lot of information back and forth that we're having, we'll be having with tip of the mitt. That's already started. And then I think lastly, what's the future? Will the HABs just go away? I will share with you, one of our theories is, were there a lot more people here in 2020 and 2021 because of, so a septic system use way higher during that period of time that might have just pushed you over the edge to create harmful algal blooms. It's a theory. We don't have data to say yes or no. I know Beverly looked at her electric bills. They were about 30% higher during that period of time when they knew they were here. They're normally not here. So is this something related that was episodic? Next pandemic, hopefully a long time. So we don't know that, but we have to be honest with our assessments. I don't want to say, ooh, look, you guys got to do something when, if this was episodic. One quick question here. So if they don't go away, we think this is an important pathway. But here's the bottom line. Septic systems it's like you drive your new car off the dealer's parking lot. You wait 1 hour, you try to sell it. You're lucky to get 90% of what you bought for. Septic system use, it's It's the waste treatment approach, but septic systems only get worse with time. You can pump them out more frequently, that extends the life, but the bottom line is these have a useful lifespan. And we see that with our data. Testing new septic systems, even 20-year-old new systems away from the lake, no problems. Older systems, they're concerned. There was one question.
So, if electric use is an indicator of time spent at the lake, can't you go to Presqu'île Electric and Gas and ask them about the rates during those periods?
There have been inquiries, but it's private data. So there are some challenges there. But again, it's a possibility, so we don't want to, wash away, because we haven't seen anything in 2022, or 2023, or 2024. So that begs the question, is this a one-time deal? I would come back and say, eventually, you're going to get there. That wraps it up for me.